by digging into your old algebra, okay, and starting really simple. This starts out really simple, but it builds to much more difficult later. Okay, so clearly the beginning is so simple for you, it will seem silly, but I'm doing this on purpose. So this is a rule, right? The rule says take the n value and subtract 5. So just maybe reading the table is the reason I'm doing this, so you know how to read the table. But you're going to do a lot harder stuff than this, but if I start with the simple, the hard stuff's going to make sense. Okay? This is in your book. These tables are actually in your book already. So you could just read along with me. It starts on page 102. So page 102. So you don't have to like write everything down. This is a deductive rule. This is deductive because I'm giving you the rule. Okay, but in the end, you're going to get the table, and you have to find the rule. That's inductive. So we're going to go like forwards and backwards. So the rule's super easy. It's like a 5th grade skill, right? You take your n value, 1, you plug 1 into n, 1 take away 5 is -4. If these numbers are decreasing or increasing at the same rate, then these will too, it looks like from this rule, because it looks like there's a pattern already. 4, -4, -3, -2. Well, the pattern should be -1, but you should also just check the rule because that pattern doesn't hold all the time. But 4 is my n value, take away 5 gives me -1. So it's not very interesting, this table. I know that. So this is going to be 0, 1, 2, and 3. So the purpose is you should be able to read the tables so you can do more interesting stuff.
Can we just call these like in-out table things?
Input-output, yep, it's an input-output table. Here's the rule, it's a little harder. So this is just a review of last year. When you have a 4 next to an n, it's a multiply. And so take away 3. So for example, right here, that would have been 4 times 3, which is what? Take away 3 is 9, right? So you should be able to plug that 4 in. 4 times 4 is 16, take away 3 is... I know you already have the answer, right? Okay, but the whole point is, I just want to make sure you could do the rule, but then also look at the fact that there is a pattern, because what happened here? We added 4, right? What happens here? Plus 4. So you should be able to find this different ways. So this is 17, right? And this is 21, right? So 6 times 4 is 24. Take away 3, and we get the 21. So the reason the rule is nice is because what if I put 80?
Yeah, you wrote it plus 21.
Oh, I did write 20 plus 21. Okay. Thank you. So if this was 80 or 725, you don't want to do this pattern, right? You want to know the rule, right? So you could skip and do 725 times 4 and then subtract 3 and stick it in the table. Okay? So now I want you to start looking for patterns between the rule and what's going on in the chart. So let's look at this chart here. How much is changing here?
-2.
Take away 2. How about here?
-2.
Take away 2. So what do you guess this is going to be? What? -3. Let's check it with the rule. What's -2 times 4? -8, right? What's -8 plus 5?
-3.
And it worked, right? So then, as long as these are going up by 1, these should also decrease by what? -2. So I shouldn't have to do calculations every time. This is going to be -5. What's this? -7, -9, and so on and so forth. Okay, so you're still supposed to be looking for a pattern with this and the rule. With this and the rule. So let's look here. What's going on here? Oh, that's a mistake. I forgot about that one.
-4.
We're gonna, yeah. This one I had a typo on, we'll just pretend it's not there.
Oh.
I know.
Why would you be so cruel to that poor baby?
Okay, so let's look at what we have. I'll zoom out here. And go back to this one. What was going on here?
The plus one.
Add one, right? Add one. Add one. Does anybody see the pattern, Kenneth?
So if the end values are consistently increasing at the same amount, the output is going to consistently increase or decrease the same amount.
Okay, in these tables, the end values are increasing at the same amount.
Which will make the outputs increase or decrease at the same amount as the previous.
In these tables, that works, but why? Samantha.
The rule that when
The rule, meaning
the
this, right?
when you're adding a number to the output, the end of the rule is a minus. It's subtract. It's the opposite operation.
I don't think that's always true.
We tested. It is there.
It could be there.
Let's test it.
But that might just be a coincidence. What else do you guys see, Emily?
The coefficient is always the same as what's being.
Do we know what a coefficient is?
Yes.
The number in front of the variable is always the same as,
What's being added or subtracted or multiplied to the next number.
as long as what Kenneth said is true, as long as these are going up by 1. That's true, right? The coefficient is -2 here. The coefficient here is 4. We see that? Okay, so that means, you guys, you should be able to find rules from tables. So look at this. I want you to, good job, Emily. I want you to look at this a little bit more now. If I look at, for example, the end value of 3 here, okay? I know that I'm going to have to multiply my end value by whatever this number down here is. So what's 4 times 3? How much do I have to adjust to get to 9?
Oh, whoa.
Okay, let's do it again. What's 4 times 5? How much do I have to adjust to get to 17? Okay, what's 4 times 6? How many do I have to adjust to get to 21? That -3, right? So let's do this table. What's 6 times -2? -12. How much do I have to adjust to get to -7? Add 5. Well, wait. Jack. Of course, Jack. Let's.
That just makes sense because it's already cool.
Okay. So, I get you. But, Jack, we're going to make a table for you. So, example A. On your table in example A, do you see these numbers?
Oh, I see how it works.
And this is my n, and you have to figure out your rule. Okay? They put it over here, in, so your rule, you can put it wherever you want.
Or do you want the whole class to figure out the rule?
Yes, Jack, I actually want the whole class to figure out the rule. But the first thing you're going to check for is that these increase by the same amount. For most, they're going to be 1s. Do you see that? So, Kate.
If you add another variable that was like the change in n, then
multiply that by 12%. So if they were increasing in 2, that, example with 4n, then there would be, if n was increasing by 2, then the output would be increasing by 8.
Okay, so we're gonna get there. She's saying if this number was different than 1, it affects the rule a little bit. It does. So if this number up here was a 2, your rule would end up, I'm not gonna spoil the surprise. It might pop up in homework tonight, but we'll formalize tomorrow. So, Connor, what do you see here?
So it goes down by 5.
It goes down by 5.
So
Check it. Okay. So what do we know here?
it's -5.
It's -5 what? N. But we have to make an adjustment. So what's -5 times 3?
-15.
It's equal to -15. But I need to get -3, so I have to add 12. That's your job tonight. Try it. Okay,
Wait,